Welcome to today's webinar. That will be an in-depth demonstration of the MyOcean Pro Viewer with dedicated times for practicing on your computer. This hands-on format directly responds to feedback we received during previous events, where many of you asked for more practical sessions. So we hope this approach meets your expectations and allows you to actively follow along. We strongly advise you to run the demonstration at the same time as the speakers, and we will deliberately pause during the session to give you time to complete the exercises. My name is Florian Caillon. I will be your host for today's webinar, and I will be accompanied by Daria Andreevskaya, who will be helping me to moderate it. So as I said before we begin, we'll go over some house rules to make sure you enjoy this session to the fullest. Please don't use the chat box on your right-hand side for questions if you're on InWing on the event webpage. It's there for greetings and for sharing links with participants throughout the session. If you have a technical or content-related question, we invite you to use the dedicated Q&A section. As I mentioned earlier, we will answer questions each time we pause for an exercise. So you can submit your question at any time using the Q&A button at the top of your screen. Simply click it to open the dedicated space where you can ask your questions directly to today's presenter. If you prefer, you can also scan the QR code on this slide to access the Q&A on your phone, for example. And while you are in the Q&A section, you will also find a short survey about today's webinar in the polls area. Feel free to complete it at any point during the session. We will also send you the survey after the webinar, so you can fill it later if you prefer. And with that, I will give the mic to Daria Andreevskaya.
Thank you, Florian. And hello, everyone. My name is Daria, and I'll be your second moderator for today. And I am here just to briefly tell you some information. So first is a participant guide regarding the guidelines and resources. We finally we strongly encourage you to go to these pages and look at the resources that are provided there. There are many interesting and important information for you about this event and the Copernicus Marine Service in general. And for the second thing to tell is about the agenda. And for today, we will have, well, first, you already got some, you get to know Florian. Florian, can we have the next slide, please? Yes, so you already know Florian. He's gonna present you an introduction to Copernicus Marine Service briefly, and then we'll move to the main part of this webinar. It is a MyOcean Pro Viewer demonstration, which is going to be led by Gabrielle Cognot and Tony Jolibois, and it's going to take us around 1 hour and 40 minutes, something like that. And as Florian already told you, we're going to have a Q&A sessions kind of throughout the whole presentation. So don't hesitate to post your questions in Slido so we can address them during the exercises part. And well, we'll have closing remarks by Florian again. So I guess now we are moving to the introduction of the Copernicus Marine Service. Florian.
Thank you, Daria. So yeah, let's start with a short introduction to Copernicus Marine Service. Copernicus is the European Union's Earth observation program. Since its launch in 2012, it has become one of the world's leading sources of operational environmental data. Its mission is to monitor our planet and provide reliable insights into how the Earth system is evolving. All Copernicus services follow the same principle. They offer long-term, trustworthy data that is free and open to all. Today, we'll focus on the Copernicus Marine Service, implemented and operated by MyOcean International. This service delivers high-quality, regularly updated ocean data, describing the physical ocean, sea ice, and marine ecosystems. These data support science, policy, coastal management, innovation, and many different sectors of the blue economy. To produce these data sets, the Copernicus Marine Service combines 3 complementary sources. The first one is in situ observations from buoys, floats, and research vessels, offering precise local measurements. The second is satellite observations, which provide global continuous coverage, and ocean models, which assimilate all observations and generate forecasts, analysis, and long reanalysis. The service offers a vast and diverse catalog, real-time data, up to 10 days forecast, and up to 30 years of historical reanalysis, covering the global ocean and Europe's key regional seas. This makes the data valuable for both scientific and operational applications. The Marine Service also supports a wide range of communities. We group these applications into 12 blue markets aligned with the 3 pillars of the UN Sustainable Development Goals, which are environment, society, and economy. They illustrate how Copernicus marine data can be transformed into actionable knowledge for decision making. And to fully describe the ocean, we classify variables into 3 families. The blue ocean, that covers physical processes such as temperature, salinity, currents, sea level, winds, and waves. The white ocean focuses on sea ice variables like concentration, thickness, and motion. And the green ocean includes biogeochemical indicators like chlorophyll, nutrients, oxygen, carbon, pH, and ecosystem-related variables. All this information is accessible through a single entry point, which is the marinecopernicus.eu website. After a simple free registration, you can browse the data store, download harmonized datasets, and explore detailed product pages that include metadata, documentation, quality information, and multiple data access options. From the homepage, just click the Ocean Products button to open the catalog. In addition to downloading data, you can explore it visually using our online tools available under Ocean Visualization. There are 3 viewers, each designed for different needs. The MyOcean Learn is ideal for outreach, education, and simplified exploration. The MyOcean Lite is perfect for quick interactive viewing of essential ocean variables. And MyOcean Pro, our advanced viewer for more detailed exploration. It allows selecting specific datasets, comparing satellites, in situ, and model data, performing custom queries, and generating high resolution graphs. These tools will be the focus of today's demonstration. So this was a quick and simple presentation for them. And I will hand over to Gabrielle and Tony, who will guide you step by step through its main features and show how to navigate layers, explore datasets, and extract information efficiently. So with that, thank you for your attention, and let's move on to the demonstration. So Gabrielle and Tony, the floor is yours.
Thank you. Thank you, Florian. So let's start by going to the viewer from the Copernicus Marine landing page. So as Florian showed you, if you go on marine.copernicus.eu, and you can go to Ocean Visualization. And first, we are not going to start with MyOcean Pro, we're going to start with MyOcean Lite. So here, and then we open this viewer, which is a light version of the one that we're going to use later, but that already has a lot of information. So what we see right now, we see the global temperature in near real time, and we see the forecast for tomorrow temperature. So already on this interface, you can change the date by sliding here at the bottom, and you can also use your keyboard to change the dates. You can also change here with the vertical slider the depth at which you want to see the temperature. So here I can go up and down and also use the keyboard. And on the left, I see that I have many different variables that I can already view in this page. So for example, here we have a temperature, but we also can see the wind. The wind here, or we can see the currents. And in this, you can already see that some gyres are forming, but and we can already try to understand why we see what we are seeing right now. So Tony, can you explain to us why we have ocean currents forming on this map?
Yeah, this is a, a beginning with a very simple question. Why are there currents in the ocean? The answer is quite simple. Wind and currents are generated by energy received from the sun and rotate because of the Coriolis force. I mean, because of the rotation of the Earth. I will keep the temperature. So you can easily see the distribution of heat in the ocean with the water temperature. Of course, warmer, it's quite obvious, but warmer near the equator and cooler near the poles. So it reflects the differential distribution of energy received from the sun. And all fluids naturally move toward equilibrium. So it is this differential distribution in space and time that sets the atmosphere and ocean in motion. Ocean circulation includes the deep thermohaline circulation, governed largely by water density. We won't see this part today, and surface circulation driven by the winds. We'll have a look at this surface circulation. So yeah, here the current, we already can parameterize the palette. Here you can see here the little button to customize the palette, and here I've just selected the color palette to have the information of the value of the velocity and not only the direction. So if I hide this, so we can easily see the ocean gyres here in the ocean. So here in the North Atlantic, the gyres go this way, and in the South Atlantic, the other way. And of course, the same. I mean, of course, the same in the other North Pacific Ocean. So here, this is clockwise rotation, and here anti-clockwise rotation. We can see also that with the wind, it's quite easy to see, maybe without the intensity. Yeah. So come back to temperature, and maybe we can have a simple use case.
Yes,
here,
a simple
Gabrielle.
use case. So now we are going to go to the full viewer where we can see everything, and we have more options than here. So here is the full MyOcean Pro viewer, which is where you have to do some exercises today. But first, I need to show you what you can see here. So again, you can see the temperature, but now instead of just temperature, you'll have the detail of what product we are using, because all the data in Copernicus Marine is separated in products that have multiple datasets. And this is the seawater data set from this global daily analysis and forecast product. So in the left, you have this little window where you can add layers to add all the products. At the bottom, you still find the same slider to change the time. On the right, you have the slider to change the depth, but you also have 5 new buttons that we're going to show you how they work later. What can be interesting for you right now is in the settings here, you can decide if you want to show the toponyms or not. You can change the language. You have Spanish and English, but for this presentation, we advise you to stick to English so you can see exactly the same thing that we do. You can increase the resolution for this visit, so it's very useful. And you can also change the units. I think by default we use international system units, but if you're American, maybe you would like to see them miles instead of kilometers on the map. So you can use this. Now you can also zoom in or zoom out on places, and that's what we're going to do right now. So I'm going to zoom in on the Mediterranean Sea here. I'm going to add back the name of the places. And what I'm going to do is I'm going to switch the color map so that it is better to see, and reset it to auto here so that we can see all the changes in all the temperatures. One thing we can do is I can put a point anywhere in the ocean, and this way I can see the temperature at that point in time. And I can also zoom in or out. I can adjust the axis. Here I can select another date to start. Like here, you can shorten the graph or lengthen the graph. I can see where I selected this point. I can see the temperature that is now at this, the date with the blue bar. It's also the date that is selected here, so 17th of January. I can see the average temperature during the period that is displayed here. So 17.76 degrees, the minimum temperature during this period, and also the maximum temperature of 24.7 degrees. I can here also export to CSV the time series that is displayed. So this can be very useful for users that don't need a lot of data. When you only need data for one point, this is the best way to do it. So, and we can close the book. Now it's your turn. So what we would like you to do is we would like you to think that you are planning a vacation in somewhere in Western Europe and you want to go to the sea. So what you will have to do is you will have to select 3 points, and you will have to use the information that is in the little windows to compare and select the best place. And for that, you can compare the different places and see when the highest temperature was in 2025 and what the temperature was. So I think, Tony, we can leave them a few minutes to manage this. Do you have other things you wanted to show?
Yeah, no, just you have removed some graphs because it's useless for this
Yes.
this use case, and here so we can zoom on time, and here this is the summer 2025, and to find the maximum temperature, this is somewhere like that, or here, okay. And when you select a time step in the time series, you have the date you have selected here in the timeline, because here I don't see exactly where I am in the timeline, but here everything, I mean, is synchronized. When I select a time step in the graph, the map behind is updated considering the time step you've just selected. So for the practical session, if we go to the good this one, okay. So you reach the viewer with the global temperature. I think Florian or someone will share the link here, or you go on the main viewer and you will have the temperature. Zoom and select 3 points in Western Europe. Delete useless graphs and keep only time series, as we've done previously. Determine the maximum temperature in 2025 for each point, and identify the date when the maximum occurs. and note the average temperature for each point over the displayed time period. So this is your turn to practice. So let's go, please.
So I think you have had enough time to test on your own to create points and compare the data. If you didn't have time, then you can always try this later. So here I come back, and I'm going to demonstrate the solution to this little exercise. So for example, if I want maybe to go here, I can move it. Or I wanted to go near Marseille, or maybe I wanted to go a little bit more to the east.
It's more near Narbonne than Marseille.
Oui, bon. Not very good with geography. And what I can do to make it easier is I can drag and drop the geometries. Maybe some of you will have found this little feature that I didn't show earlier. I can remove the graphs and then set the axis to 2025.
C'est les mois. Ouais, très bien. 2026.
26. Up, and now I can see that all of my points they all have a letter B, C, and D. And at D, the temperature is higher than at C and than it is at B. And that I can see that the best time to go is to go to D in the Adriatic Sea in July, and we almost get 28 degrees. Contrary to this, if I go here at B at the same time, we barely get 20 degrees, and for some people it's okay, but for some people it's too little. Now this was a very light exercise and very light use case to show to you. Now we will move on to less fun examples with marine heat waves. So I will give Tony the floor to tell you more about marine heat waves.
Yeah, thank you, Gabrielle. So yeah, we'll continue this session with marine heat waves. Humans, of course, know about heat waves in the atmosphere, but fewer people know that heat waves exist also in the ocean. Mercator scientists make a weekly bulletin on marine heat wave available on Mercator website. So I think the URL will be shared in the chat to the Mercator Ocean website. So we've splitted this use case of the viewer in two parts. First, discover the products, customize color palette, and so on. And second, characterize marine heat wave with graphs. So we will work on Mediterranean Sea. So on this layer control, you can delete or add new layers in the catalog. So here you can discover the products. So there are more than 300 products, so it can be a bit difficult to find your way in that such complex catalog, but hopefully we have filters to find our way. So for the monitoring of marine heat waves, we want to see temperature. So this is the main variable filter. We want to work on Mediterranean Sea. So here there are the areas with all the areas covered by the different products. So here 16 products. This is a bit better. So here we have the new real-time model output, the reanalysis model output, Okay, I will add to map the temperature daily of the new real-time model output. Okay. Okay, we see here that we are in July. The color palette is a nightmare, so we have to customize it a little. So again, as Gabrielle said, you click on this button to customize the palette, and the automatic customization of the palette is quite helpful here. But we want also to see, so as Florian said just before, we have different source of data. We have the numerical models, and we have observation, the in situ observation and satellite observation. So if I select satellite observation here, we have here the level 3 and level 4 satellite data with quite very high resolution. This is interesting. So we're gonna add the temperature anomaly and also the temperature. Okay. So the anomaly. Yes, please. Thank you very much. So again, the palette is really not adapted. Here we customize it with the auto button. Okay. And to go deeply on the comparison between the different layers, we're gonna customize the minimum and the maximum of the color palette, fixing it to 10 for the minimum and 30 for the maximum. I will switch the order here of the layers, and I will parameterize the same minimum and maximum with this layer, which is the model output. Okay, so here, and you have the sea surface foundation temperature, and you have an information button here to have details on which product this data come from. Okay, so this is satellite observation. As mentioned here, you have all the metadata on this product, the resolution, the temporal coverage, etc. Okay. And of course, the same here for the other layer. So this one is the model output with exactly the same characteristic. I mean, the characteristics are listed here. So to compare, for example, a bit the different layers, you can hide and the different layers here. So this is the model output, and this is the satellite observation. You can play also with the opacity. If we zoom a bit to see more details. If you play with opacity, okay, you hide progressively the satellite temperature, and the other layer appears progressively also. So fortunately, there are not so many differences between the two, but the satellite observation has really a higher resolution. and but whereas the model output has forecast. So it depends on what you want to do on this way. Where I am.
Now you move on to the marine heat wave definition, maybe?
Yeah. Yeah.
You can show
Yeah. Okay. A marine heat wave is defined. So we're gonna then switch to. Yeah, I think this is the practical session for discovering the product. No?
Yeah, I think it is, yes.
Yeah. So
I think it's time for you to play around with MyOcean and the catalog.
yeah. So this yeah, you go, Gabrielle.
Okay, we can go. So now it's your turn to find the products that Tony used in this example. So you have to go on the top left and click on Add Layer, and then in the catalog, search for the products. So the first product was the Mediterranean Sea high resolution and ultra high resolution sea surface temperature from the satellite observation. So you can use the keywords to find this product. And the other product was the Mediterranean Sea physics analysis and forecast. So again, you can find this product in the catalog. And then you have to you can change the visibility of the layers, display order of it, or hide or show layers by click on the I button, and customize the color palette so that both layers that show the same variable, they match, and see how the resolution changes on the picture that you are viewing. So you have, I think, 3 minutes.
Yeah, something
5
like
minutes
that. Yeah.
to play around on your own, and we'll let you have fun.
Okay. I hope you had time to practice a bit the discovering of the product. Florian, maybe there are some questions you wanted to speak about.
Yes, we received a few questions for the presentations you made so far. I will select a few before we can move on. There was a question about how to get specific data like nitrate and phosphate in the viewer. Maybe you can go a bit
Yeah,
more in detail.
yeah. You mean what is exactly the question? How to discover nitrate and phosphate?
It's more like where can I get nitrate and phosphate data?
In the catalog. So this is a other main variable, and so if I clear my filters, there are in the main variable the nutrients. So here you have oxygen, carbonate, and so on, or maybe easily the green ocean. And then in the green ocean, you will find all the biogeochemical variable available in the catalog.
And if you want, you can also use the free text search bar at the top, and maybe we'll find a product that has the words in the description.
Mm-hmm.
So again, same green ocean.
Nice, thank
Do you
you.
have questions, Florian?
A question with the same same spectra is how to obtain data with latitude and longitude coordinates.
So that's a very good question. So if you're interested in only one time series at one location, and you don't want to have to find it on the map by moving around and finding your points.
Je vais montrer peut-être.
Ah ouais? We will show you later.
Yeah, you mean the points and the time series?
I wanted to show how to import specific points in the map.
Okay.
So we have a feature here in the import on the right. And if you click here and you go to here when non-text, you can write a point. So for example, this point that is given here, I think it was 668. So longitude and latitude, and click on import. And it will create a point. So there's no data here because we were on the MEDC dataset, but if it was in the MEDC, it will have a graph. And that creates a graph, and you don't have to be to click at the specific point you wanted the graph to be. And then, as I showed you earlier, you had the options on the points. When you have a graph, you have the option to export, for example, here. You have the option to export to NetCDF, CSV, or export the image to SVG. And that's how you can get the data for one specific longitude, latitude point. I hope that answers your question.
Thank you. Do you want to take another question or?
Maybe we can move forward.
Yes,
No?
we'll take other questions later.
Thank you.
And also we'll send you a post-event report at the end of the session so that every question will have their answers at some point.
Thank you. So to monitor, so I remind you that the use case here is the marine heat wave monitoring. So to monitor marine heat wave, so maybe as you mentioned, Gabrielle, the definition of a marine heat wave is defined as one where the measured temperature is within 10% of the maximum values observed for at least 5 consecutive days. So it can be seen using the temperature anomaly we are seeing here. So seawater temperature anomaly is the difference between a seawater temperature measured at a given place, so here on the Mediterranean Sea, and time. So here, beginning of July 2025. And it's so the difference between the measured temperature and the normal value, the reference, usually taken from a long-term average. Okay, so we consider marine heat wave when it is around 10% above the reference. So you can customize the color palette here to see that more easily with this feature to put dashed areas where temperature anomaly is temperature is above 2.5 degrees above the reference. So what I wanted to demonstrate is yeah, the situation in the summer 2024. Okay, so we browse here the summer 2024, beginning of July. Okay, and we want to work on a specific area. And to do that, we have here the area button so that we can draw an area here. So if I want to work, for example, on the Ionian Sea, okay, so I draw an area here. So to do that, I click, and when I'm happy with the area, I click on Escape on my keyboard, and then it generates graphs with of course, the variable we've selected before. So here we have a time series of the sea surface temperature anomaly averaged on the area I've just drawn before on a time series, okay? And I find the dashed region, I mean the dashed area I have just customized before in my color palette. So all the temperature that are above temperature anomaly that are higher than 2.5 degrees compared to the reference are dashed. So we are here in 2024. So if I zoom a bit on the summer 2024, we see here quite easily a quite heavy period when, if I reach here the time step, we can see that for this period, the temperature was higher than 2.5 degrees compared to average. So we can characterize here a marine heat wave between beginning mid-July 2024 to here the end of July 2024 on this area, okay? So this is quite easy to see in that kind of graph to characterize the marine heat wave. So if I adjust axis to have only the 15th of June, so 2024 to the end of August, no, August 2024, okay. I apply, so the time series is updating on the period I have just selected here. So here I have statistics on the period I have selected, so we can know that the temperature on this area, temperature anomaly, sorry, is 2.34 above reference on the average, both on the area and on the temporal coverage I have just selected before, so between the mid-June to end of August. We have also the minimum and maximum of temperature anomaly. So with this kind of graph, we have a lot of information here. So we wanted you to discover that. So if again I adjust axis to only July, here 7 to 30, okay. So the graph is updating, and then I have the same statistics on the month of July 2024. Okay, so you remember customizing the color palette with the dashed area using this button. Draw an area using the button area just on the right of the display. So you click to draw an area and you escape on the keyboard to finalize your area, and you have this kind of graph. So I think this is your turn to practice a bit. So if you were in the previous visualization with the different layers of sea surface temperature, we invite you to delete the temperature layers in the control. So very easy with the button to delete the layer. Draw an area in Ionian Sea, so just to keep only a temperature anomaly. Draw an area in Ionian Sea and make an analysis of the situation during the summer 2025. So I've showed the situation on 2024. So here, if you can do it for the summer 2025 between June and August 2025. And as an additional question, if you have time, to see what is the average and maximum temperature in June 2025, temperature anomaly in June 2025 on the selected area. Oh, there was an export of the image, so maybe I can show it just very quickly. So to export an image, there is this share button here on top of the layer control. And here you can copy a link, a permalink to share the same situation with a colleague or a friend.
That's the feature that we have been using to show you pre-prepared viewers for the training. So it's very useful.
Yeah. Or you can share image with the color palette, with the nice labels and so on here. So here, download in high resolution, you can download a high resolution image here. So that's the way you can export image. So your turn, please practice a bit. And if you have questions on this practical session on marine heat wave in Mediterranean Sea, please post it in the chat.
No, not in the chat, in Slido.
Sorry, in Slido, sorry. Okay, so I think we have questions on the session, on the practical session. So Florian, you want me to?
Yes, I can transfer a few questions. One was, can you make the SST anomaly dashed be based on a percentage instead of a fixed temperature? Because it won't.
Very good question. Thank you for that. Unfortunately, no, it's not possible because yeah, for the moment we only have a fixed value. But yeah, very good question, because as I said, the marine heat wave is defined with the 10% of higher than the value of the temperature. So I took 2.5, yeah, as a threshold, because yeah, seawater temperature in Mediterranean Sea during summer is approximately near 25 degrees. But thank you for that. It's a very good question. Thank you.
Thank you for a very good answer. There's a next question for the anomaly. Under the coordinates, you have the statistics for the actual year. well, is it the statistic for the actual year? For example, if you select summer 2024, do we also have the statistic data for 2025?
To do that, you have to navigate on the time window. Here you have the plus to add the more temporal coverage to the graph, and you can reach the summer 2025 here by clicking on plus and plus and plus.
Or you can change with adjust axis. So basically, the statistics that are shown at the bottom of the graph are the statistics that stand for what is displayed in the graph. So if you want 2024, then you have to put 2024 the whole year in the graph. And if you want 2025, then you change to put only 2025. I hope that answers the question.
I guess. Well,
Okay.
I understood at least. And for the last question for this Q&A, how do you delete an area from the viewer?
Just by clicking on the cross here. If you click on the cross here, you delete all the area. Okay. So if I make again the area.
Very good question to see 2025, since it's the example that we wanted you to try out in this practical session.
Yeah, so as you mentioned, Gabrielle, maybe the most simple way is to adjust the time axis to, for example, July 2025. So if I do that, I apply. So of course the graph is updated, displaying only the temporal coverage we've just selected, and the statistics also apply on the temporal coverage we have selected. So here the temperature anomaly averaged on this area and for the month of July 2025 is 1.85 degrees above reference.
And for the reference, is it taken from what does the anomaly compares to? Is it a 30-year period?
Yeah, it's a period, if I remember well. I don't know if it's written directly in the product sheet. I don't think so. This is a detail that you can find in the quality information document, but
user manual even.
Yeah, also in the user manual. Yes. But this is something like the period is from 1993 to 2020, something like that. So it's near 30 years period. So it defines a climatology, so a reference for each month of the year. So again, yeah, you will find this kind of detailed information in the user manual, in the quality document, and so on. I think I don't know if we will take time to to see that. Oh, yeah. So the climatology here, so this is not 1993, this is 1985 to 25 period. Okay.
Okay, nice. Well, I think we can
Thank you for
move on to the next part.
Okay.
Yes.
So next one is we're gonna get cold.
Yes, it's going to get ice cold now. So I will remove this layer. And now we want to illustrate a specific point. So this statement was published by Copernicus Marine, and in September 2020, the Arctic sea ice reached its second lowest point, its second lowest extent since 1979, behind a record minimum of 2012. So we want to see when the sea ice extends at the poles. So we're not going to do a whole catalog search again, but I will add a layer, and I am interested in sea ice. So
you have to clear your printer.
Yes, clear filters. I am interested in sea ice. No, sea ice. I'm interested in by both poles, so I will select global ocean, and I want a long-term analysis, so I will select the global ocean physics reanalysis, because this product has a very long time coverage. You can read it here, when this one only has the most recent data. So for long-term analysis, the reanalysis products are usually more interesting because
because of the quality, a reanalysis dataset has better quality because it is produced after the fact, allowing the assimilation of all available observation, including delayed mode data that have been quality controlled. So it means that, reanalysis, when you look at the past period, you have a better data quality than the new real-time product.
Yes, so thank you, Tony, for this. Now you can see here, but you can't see anything because the poles are not showing. But in MyOcean, you can switch to the north polar projection here, but a little here. So we are now in July 2024, and we see the sea ice extent because we chose sea ice area fraction. And we can also move back here, scroll back, and then go to the South Pole at the same time. So in July 2024, yes. I think it takes a bit more time to load because we are sharing the screen. So you can see here the sea ice.
Yeah, if you see maybe the minimum of sea ice extent in Antarctic. So
it's in February because it's a winter when it's a summer for us. And it's the summer when it's winter for us. So February, I don't know.
Yeah.
Here you can see that in February 2023, there's only this that's left, and you can continue to go in time.
So here Gabrielle is using the keyboard arrow to navigate on time.
Yes.
Yeah, it's quite.
But, I don't know if you're seeing everything properly, but if you try it on your side, because I think Florian can send a link in the chat to that same view. You can see also the evolution. But now, if you want to share this information with someone else, maybe you would like to show a video or a GIF of this. So what you want to do is you go to here, you share, that Tony already showed you earlier when we showed you the link and image feature. And you can go to a video tab. And so then you can create a video, for example, of 1 year.
Parce que les mois sont en
Ouais, je donne, for example, of 1 year. And put a time step that is not too hard on your computer. Especially here we have monthly data, so it's not very useful to put 1 day. You put 1 month and you click on generate the video. And it takes a while to generate. And then instead of generating and cancel, you will see a little download button and you can download this. Like it will load here. And what happens if you put like 1 day and select a whole year is that it will just crash your MyOcean viewer window. So please don't do this. I have tried. All right. I think maybe I could leave you a bit of time to explore this sort of analysis. So maybe the 2020 minimum CI extent. What do you think?
Yeah, but it's time for practical session.
Time for a little practical session.
Okay, so I
will just cancel this. It takes too much time, but it will not take that much on your side. It's the presentation is already taking a lot on the computer.
Yeah, but I mean, it takes time to generate.
Yes, but it doesn't take that much time with 1 month time step.
Yeah,
it takes a few seconds. You need to be patient.
So the next practical session was that. So
2025.
Check the minimum ice extent in Antarctic in February 2025. Generate a short video displaying the evolution. Antarctic or Arctic. But,
I thought Antarctic. I already showed you the Antarctic, so let's change this. Maybe. Let's change it and see the Arctic then, since I already showed you.
It
won't be in February, but you need to find when it is.
Okay. Yeah.
September.
Yeah, near September.
So, and we'll give you a solution when that is.
Florian, you have an URL to share with the participant, I think. If you can confirm.
Yes. I think it's sent to the chat. I don't have the URL for the Antarctic.
Sorry?
I don't have the URL. Sorry, I don't have the URL for the Antarctic. So I sent the Arctic one.
Okay, but no, it's okay because the data covers Antarctic and Arctic. So I mean North and South poles. But if the view, if the link you've shared is centered on, I don't remember, Arctic or Antarctic.
On the Arctic, yes.
On the Arctic, so you can do what you want with pan and zoom. And again, as Gabrielle showed earlier, we are here in the stereographic north projection to see something on the Arctic. Then with this button, we switch on the geographic projection. So this is quite the simplest projection to see the world. X equal longitude and latitude equal Y, and the south stereographic south projection can be reached with this one. So we checked Antarctic, then you can play on your side, please, with the viewer and check the Arctic.
Yes, minimum extent in 2025.
The minimum extent in 2025. So for those who lives in the North Hemisphere, it's quite easy to know the end of summer when the ice extent is at its minimum on the North Pole.
I see a question about the format for month, day, year. Is it if it's for the date inputs when we change adjust the axis or when we export the video? I believe it is set by your browser settings. So if you have, for example, if you're French, you have day, month, year. Or if you're American, you have month, day, year.
Yeah.
That's the settings on Tony's computer, but on mine, it's day, month, year.
Yeah.
You can't choose this. You have to set your browser settings.
How can you use image by GIS to find data? Yeah, GIS. You can import NetCDF data or use the WMTS service. So here, if I click here on information, there is. So here, this is the product sheet of the data just displayed. You have this data access tab here. And here, so you find all the data sets which are included in this product. So this is the global ocean reanalysis produced by Mercator Ocean. So there is the daily data set, the monthly, and the climatology and other statics. And you have here WMTS URL. It means that you can, so WMTS for Web Map Tile service. This is a standard service to be read by your GIS tool. Another way maybe is to download the data, and if your GIS can do that, import the NetCDF you've just downloaded before. Okay. Okay. Will we continue with the question or as you want?
Someone tried to do a video of 20 years. I don't think you can do it because if it creates a black video, that means your computer didn't succeed in making the video. You can't export an image of a map with the plots in it. And this is something we need to discuss if we want to implement this or not. But for the moment,
including the graphs?
Yes, including the graphs. Maybe that would be a little busy on your image. So you have to export the graph and the map separately, and if you want to have them together, maybe use Paint to put back the graph in the map for now.
No, I mean, or you make a screenshot.
Yeah, or make a screenshot.
This is the only way to have
Yes,
for the moment.
to have both at the same time. But that's a very good question.
Okay, so maybe we gonna
show you the solution and move on to
so the solution for the
minimum.
the minimum extent. So yeah, if I draw an area here, something like that, and I have here.
Please be patient.
And here, so this is the average value of the sea ice area fraction on time. So in 2025, this is
Yes. Here
something here.
we have the actual data.
Oh yeah, this is monthly data.
In September 2025. So end of the summer, most of it has melted and will retreat in the winter.
Yeah.
Yes. So you would have two possibilities to find that minimum, either empirically move forward and backward in time on the slider, or use the areas feature to find more exactly when the minimum is. That's a very good feature to use for this kind of study.
Okay, so I'm gonna switch to the last story on the ocean we wanted to show you, which is the upwelling. So mass concentration chlorophyll in seawater. So we're gonna switch to the green ocean. Here you have so at on the display the mass concentration of chlorophyll in seawater. So I want also to add primary production. So I filter on plankton. So this is the biogeochemistry model with the primary production, maybe daily. Okay. So yes, primary production is the process whereby inorganic carbon is fixed in the sunlight, so the euphotic zone of the upper ocean, and forms the base of the marine food pyramid. It occurs when marine phytoplankton use sunlight, energy, and dissolved nutrients to convert inorganic carbon to organic material, thereby releasing oxygen. So this is the first, something on the chain of the food chain of the Earth. So you can see here the distribution of the primary production in the ocean, and there are vast unproductive low and mid latitude ocean here, and I mean in the open ocean. Warm and sunlight surface water is separate from cold, nutrient-rich interior water by a strong density difference that restricts mixing of water. So we're gonna analyze that. I don't remember what is the practical session, but
The lines.
it lies on the African coast.
Yes,
no?
lines, yes.
Yeah, okay.
So what you can see here is that on the west coast of Africa, but also on the west coast of South America, you have a very strong concentration, very strong net primary production of biomass. And this is due exactly to what you described,
Yeah.
mixing of water, which allows for the phytoplankton to develop more in these areas than in other areas. So what Tony just did is use the lines feature on the bottom right of the screen to create longitudinal profile on the map on the West African coast. And then maybe Tony, you can describe what is shown in the graphs that are displayed when you create a line.
Yeah, so this is here a section of the data above the line. So here, this is the value of the net primary production along the line, the line I've just drawn, and in depth. Okay, so you can see here where the primary production has a high value. Of course, we see it here in the open ocean. It's quite low, and near the coast there is the upwelling. So I will add to graph other variable to characterize that. So here, if I select seawater potential temperature, and okay, I select, I don't know if Florian, you can confirm that when I click on that in the shared window, you can see the list of the type of graph we can do. I'm not sure.
Yes, yes, we can see.
Okay, great. So here, and so this is the value of temperature, vs distance and elevation. Okay, so I add graph.
So to the add graph, you can add any graph of any variable that you have in your layers on the left of your screen. So you can choose anything that is within the variables that are displayed right now.
Okay, and I add a final one, a last one, with this time the chlorophyll in seawater. So this data set, chlorophyll in seawater, doesn't have elevation. This is a satellite observation, so I cannot make exactly the same graph as the others, but there is a quite interesting one with the distance and time. So in these graphs, you don't have the time. I mean, this is the time on March 2024. Here, we're gonna switch to present. Okay, and I add graph here on the chlorophyll. So here, this is a different graph. There is the time as the y-axis, and on x-axis, this is the line, the distance on the line. So here I move this here, and we're gonna compare. Let's make some place, and we're gonna compare. So again, I click on line, and I will go in the Gulf of Guinea. Sorry. If I am able to draw a line, thank you very much, something like that, on the Gulf of Guinea, and escape to generate the graphs, sorry. So I remove this one, and again, I add. So the temperature is very important to characterize an upwelling, distance and elevation, add graph. And as the other one, I will add chlorophyll with distance and time. So there are big differences between these two lines. Here in the temperature, you can see a very high stratification of the ocean. By stratification, there is a clear separation between the hot temperature water and the cooler one. And there is no mix between the two. Whereas here, there is a clear mix, a mix of the water temperature near the coast because of the wind blowing parallel to the coast and generate a current that goes towards the open ocean. And then with this movement, the cooler, we can see here very clearly, the cooler water go on the surface when the water, the hot temperature water is pushed away
from the coast.
Yeah. So here, no upwelling, stratification of the ocean. We can see here on the net primary production that there is no clear high values of net primary production, whereas here the cooler temperature go on the surface and there is a clear bloom of primary production near the coast. So it has a huge impact on the economy, on the fishing activities, and so on. So it's quite important to see that. And last but not least, this graph here help us finding the period where the upwelling is the most important, with the highest value of net primary production and or chlorophyll here. So we can see here between we are here August 2025 and the beginning here of December 2024. So you can easily navigate on time with this. And we still see here that there is stratification of the ocean and no high primary production. So there was a news in 2025 on the upwelling on Panama. In 2025, the Gulf of Panama experienced a major ecological upheaval with the disappearance of the upwelling, a phenomenon crucial to marine ecosystems and local fishing. So if we go to the Gulf of Panama, maybe I will keep. So the Gulf of Panama is here. I'm checking here the chlorophyll. So the news, if we select in the timeline February 2024. Oh my God. Again, blah, blah, blah. Sorry, I have to do that. I cannot reset my timeline. Thank you very much. So, February 2024, looking at the Gulf of Panama, we can see here quite easily the high chlorophyll values in the Gulf of Panama. We have here a clear upwelling. Okay, looking at the temperature, customize the color palette. Okay, you can see here the low value temperature and the high value chlorophyll. This is a clear upwelling. And if we navigate to February 2025, this is clearly not the case. We see here a low value of chlorophyll and also a temperature, hot temperature of the ocean. So this is a clear illustration of the disappearance of the upwelling in the Gulf of Panama when we compare February 2024, but we could also compare more in the past. Here, a clear upwelling here, whereas in 2025, the upwelling has disappeared. Okay, do we have a practical session for?
I don't know if we still have time, but maybe.
Yeah, it's 11:43. There are some questions.
Yes.
Okay. Sorry.
So we had a few questions. Maybe Florian, can you ask us a few questions? Please?
Yes, of course. Someone asked for how to cite the products when they're used in a publication, for example.
Yes. So for this, can you move
Yeah.
the mouse? So for this, you can go click on the I layer information, and here in the tabs you have how to cite, and you have an article that tells you how to do it, and you can use the DOI of a product. For example.
Yeah, here
Right,
everything
yeah.
is explained.
Is explained in
yeah.
this Help Center article.
Okay, nice. Thank you. Someone also asked for, is there an API for real-time integration of data?
Yes, so we didn't talk about this today because the scope of this presentation was the MyOcean Pro, but you can definitely automate downloads if you want a lot of data, or if you want to routinely run the same analysis. And for that, you go to data access. No, not data access. Downloads here, and you can automate. Click on automate, and you have commands that you can use either in a command line interface or in the Python API. The package is named Copernicus Marine, and you can find articles in the Help Center, which we'll introduce just later, to learn how to use it, or you can find maybe other training sessions that are more focused on the toolbox. To access the help center, because you might have questions that we can't answer today, you can find the chat here, talk to an expert, and so here you can either find articles, search for help here, for example, install toolbox, and you can find an article to teach you how to install the toolbox. And if you don't find an answer to your question, you can always ask a question to the chat. So Blue is an AI chatbot that has access to all the knowledge from the documentation. And there's also a team of humans, including me, that can reply to your questions. So we won't leave you alone. So, and you also have some news, for example, here the latest news from Toolbox, which had been upgraded not long time ago.
So the Copernicus Marine Toolbox, as Gabrielle said, it's the package, the tool to use if you want to download data regularly or if you want to download data through a programmatic interface, avoiding the click, interactive click thing.
Yes, or if you want to customize all of your plots because you don't find what you want in the viewer, but you have a lot of things in the viewer already that you can use.
There's a question regarding this from someone who said, does the MyOcean Pro Viewer aim to eventually replace advanced tools like the Copernicus Toolbox, or is it designed to be a complementary entry point? And what is its unique value proposition for power users who are already comfortable with API-based data processing?
No, I mean, the MyOcean Pro Viewer allows to visualize data, whereas the Copernicus Marine Toolbox allows you to download the data. I mean, you can download the data from the MyOcean Pro Viewer, but the Copernicus Marine Toolbox really focuses on download data, and if you want to download large data volume, you are welcome to use the Copernicus Marine Toolbox because it's much more in the operational way. No, this is a programmatic interface, and that allows you to make some loops or to make a quite robust request to download data. Can be regular downloads or punctual downloads.
Also, what can be useful with a viewer is that if you're not downloading anything, you don't have to be registered to access. So anyone that just wants to browse, or if you just want to share a view and show it to someone, they don't have to have an account at Copernicus Marine. Of course, to download with the API, you have to have an account. Oh.
Nice. Thank you. Do we have time for other questions, or do you want to proceed?
Yeah, maybe one or two questions.
Yeah, maybe one, two last questions.
There's a question about the last demonstration. Someone asked, where are you getting the net chlorophyll? Because in the link we shared, there's mass concentration.
So what is the source of the data?
I think it's more how to display the net chlorophyll instead of just mass concentration.
Okay. So sorry. So here, when you want to add another data to your display, you click on Add Layer, and it can be you can use several ways, but here, if you select in the main variable plankton, value of the filter. Here you have the model output, near real-time model output and reanalysis here. So if you add to map this one, if you are working on the global or outside Europe, so here there is the primary production and oxygen daily or monthly. Okay. So this is the title of the data set, and here you have the quite complex standard name of the variable. So it's quite long but well defined, and I mean a unique. This is a unique name, identifying clearly and in detail which variable you are adding to your display. Okay, and then you add to map, and it appears on the display.
Nice. Thank you. Someone asked, like, what is the most efficient way to extract a data set of multiple layers for multiple locations across a long time range?
No, definitely the toolbox, but maybe not in MyOcean Pro.
Yeah, I totally agree. Of course, when you want to download data I mean, with a lot of data in here, different locations on a big time period, etc. You definitely have to use the Copernicus Marine Toolbox. There are plenty of features in the Copernicus Marine Toolbox. I mean, you can extract data on geometries and so on. So this is not the subject of this training today, but there are, as Gabrielle said, several articles in the Help Center which will help you using the Copernicus Marine Toolbox. And again, this famous and high competent user support team.
Yes. They're listening right now.
Who will support you in your complex request. If Blue, the AI agent,
isn't fast enough.
Yeah, did
Yes.
not answer in detail your question. So don't hesitate. But I think the chat is available for logged in users.
No, everyone can see.
Okay.
Everyone can, but everyone in this training already is logged in
Okay.
because they needed to be logged in to access to the training. So it's not a problem.
Okay. Okay, great. So when I go home, you say, "Hi, Tony." Oh, wow. And
Yes.
they don't say, "Hi, Tony and Gabrielle."
No,
No,
it's Tony.
because we are okay.
It's your
not
computer
being,
with you. Okay, maybe that concludes the questions. Florian?
Yes. Well, thank you for both of your presentations. I have a few more words to say to the participants before we close today's session.
Stop share.
Just so you know, we will have a similar presentation as today, demonstration focused on the toolbox later this year. So just stay tuned on the Copernicus Marine website to get updates on which events we are programming, if you want to know a bit more in detail how to use it. Again, thank you very much, Gabrielle and Tony, for your demonstration today. I hope it was very helpful and useful to our participants. One last reminder about replays and polls. You'll find both of these on the event website through the menu at the top of the page. We will also send you an email to let you know when the replay is available and a link to the poll about today's webinar. We value your feedback, so please, if you have a little bit of time, just answer the poll. If you'd like to go further after today's session, I encourage you to visit the Copernicus Marine Service YouTube channel, where you'll find a rich library of webinars and training sessions from the past few years, all freely available. Each video focuses on a specific theme, whether a region of the world, a blue economy sector, or a practical example of how ocean data supports real-world applications. So it's a great way to deepen your knowledge at your own pace and explore use cases that match your interests. You can also discover all Copernicus Marine events, both upcoming and past, via the Events tab in the top right menu of the website, where you can open any event page for details and registration. Thank you all for joining today's session. We hope you find the demonstration useful and that you now feel more confident navigating the viewers and exploring Copernicus marine data on your own. Have a great rest of your day and goodbye, everyone.
Bye-bye.